Here, find the indefinite integral. Here, notice that when we take the definite integral, gonna be f of x plus c. So the antiderivative and then plus c, and that's called family of antiderivative. So let's move to part A. We have the integral of 5x plus 7 dx. So we're gonna use the properties of the sum. That's gonna be the integral of the first term and then the integral of the second term. Now notice that I'm gonna pull the constant out of this integral. Now notice on the second integral there is a 1 when we pull the constant 7. It's not 0. Now notice that the integral of x to the 1 dx here and gonna be equal to 1. Therefore that's gonna be equal to x 1 plus 1 over 1 plus 1 plus c. Gonna be x squared over 2 plus c. For the second integral, we have the integral of 1 dx. That's gonna be just 1 multiplied by x and then plus c2. So it's gonna be 5 and then multiply by x squared over 2 plus c1 and then plus 7 multiplied by the resulting of the integral, which is x plus c2. Now I'm gonna multiply 5, what's inside in the parentheses. I'm gonna multiply 7, what's inside in the parentheses. Now notice 5c1 and then plus c2, I'm gonna equal that to c. Therefore we're gonna have 5x squared over 2 plus 7x and then plus c. And that is the resulting of the indefinite integral. For part 2, we have the integral of x plus 3 squared dx. Here, I don't know how to integrate this function, so I'm gonna try to rewrite it. I'm gonna use a plus b squared equal to a squared plus 2ab plus b squared, where a here is x and b equal to 3. So x plus 3 squared gonna be equal to x squared plus 2x multiplied by 3, then plus 3 squared. Then gonna be equal to x squared plus 6x plus 9. So the integral gonna be equal to x squared plus 6x plus 9 dx. Now I'm gonna use the properties of the sum, so that's gonna be the integral of each of these terms. Now what I'm gonna do, I'm gonna pull the constant out of this integral from the second and the third integral. Now notice the integral of x to the n dx is equal to xn plus 1 and then over n plus 1 plus c. So the first integral gonna be equal to x cubed over 3 plus c1 and then plus 6 multiplied by the resulting of the integral, which is x squared over 2 plus c2 and then plus 9. And then remember the integral of a constant gonna be that constant multiplied by x. That gonna be 9x plus c3. Now I'm gonna simplify 6 over 2 in the second term. That gonna be 3, and then I'm gonna distribute 6 to the parentheses. Now notice that c1 and then 6c2 and c3, I'm gonna add all these constant and equal them to c. So that we will have x3 over 3 plus 3x squared plus 9x plus c. And that is the resulting of part 2. Notice in here we will have a shortcut for c. So this is what we did. For part 1 and part 2, we use the integral properties of sum. So remember the integral, in this case we have two functions. So integral of sum of two functions is going to be the integral of the first function plus the integral of the second function. And the resulting of the first integral is the antiderivative f of x plus c1, and the resulting of the second integral is g of x plus c2. Now what we did is we added these c's together, c1 and plus c2 gonna be equal to c, and therefore the resulting is f of x plus g of x and then just plug c. Therefore, when we have similar situations in here, when we're given the integral of sum of function, we're going to take the antiderivative of each function and then just add plus c in the end. And that is the resulting antiderivative. Part 3, we have the integral of 4 e to the x minus sine of x dx. Here I'm going to use the properties of sum. The integral of sum is the integral of each of functions. Note in here, the integral of e to the x dx is just e to the x plus c. And then the integral of sine of x dx is going to be equal to minus cosine of x. Therefore, the integral of minus sine of x dx is going to be equal to cosine of x. Now that's going to be equal to 4, and then multiply by the integral of e to the x, which is e to the x. And then plus the integral of minus sine of x, which is going to be cosine of x, and then we added the c, so plus c, and that's the resulting of that's the antiderivative. Now for part 4, we have the integral 3 over t minus 2 over t squared dt. That's going to be equal to the integral of each term. Now here I'm going to use the integral properties, so I'm going to pull the constant out of the integral. And then for the second integral, I'm going to bring t squared in the bottom to the top, so it's going to be t over to minus 2 dt. So we'll have 3 and the natural log of the absolute value of t minus 2. And here, what I'm going to do, I'm going to use t minus 2 plus 1, and then minus 2 plus 1, and then plus c. Now I'm going to take the middle term and try to simplify that. T to the minus 2 plus 1 over minus 2 plus 1. That's going to be equal to t to the minus 1 over minus 1. That's going to be equal to minus 1 over t. So I'm going to substitute that into the left. That's going to be minus 1 over t, and then we don't forget the c. Therefore, that's going to be equal to 3 natural log of the absolute value of t, and then plus, since minus multiplied by a minus is plus, and then we don't forget the c.